Building on our knowledge of OOP, we'll explore how Python organizes code at a higher level using modules and packages. These are fundamental concepts for creating maintainable, scalable applications. Modules allow us to organize related code into files, while packages help us organize related modules into directories. This structure is crucial for building larger applications. Today's lesson builds directly on our previous work with OOP and file operations. We'll learn how to organize our code into reusable components, making it easier to maintain and scale applications. Understanding modules and packages is crucial for working with larger codebases and utilizing Python's vast ecosystem of third-party libraries. A module is simply a Python file containing code. It can contain functions, classes, and variables. Modules help organize related code into manageable units. When you import a module, Python executes all code in the module and makes its contents available to your program. This is the most basic form of code organization in Python. Python provides several ways to import modules. The basic import statement imports the entire module under its namespace. Using as creates an alias for shorter references. You can import specific items directly into your current namespace. Importing everything with asterisk is generally discouraged as it can lead to namespace pollution. For readability, you can break up multiple imports using parentheses. Aliasing works with individual imports as well. When working with packages, you can import from nested modules using dot notation. Choose the import style that makes your code most readable and maintainable. Namespaces help prevent naming conflicts between different modules. Using the full namespace, module.attribute, makes it clear where names come from. When importing directly with from, names enter the current namespace. Be careful with naming conflicts when importing from multiple modules. Consider using full namespaces for clarity in larger programs. A package is a way to group related modules together. It's essentially a directory containing Python modules and a special __init__.py file. The __init__.py file marks a directory as a Python package, and it can be empty or contain initialization code. Packages can contain sub-packages, allowing for hierarchical organization of code. When creating a package, organize related functionality into separate modules. Each module should have a specific purpose. The __init__.py file can be empty for simple packages. This organization makes it easy to find and maintain code. Consider the logical grouping of functions when deciding module structure. The __init__.py file can define what should be available when importing the package. The dot notation, .module, in imports indicates relative imports within the package. __version__ is a common convention for package versioning. The __init__.py file controls the package's public interface. Python looks for modules in a specific order: current directory, Python path, and installation-dependent defaults. sys.path shows all locations Python searches for modules. While you can modify sys.path programmatically, it's better to use Python path for custom module locations. Understanding the search path helps debug import issues. Absolute imports use the full path from the root package. Relative imports use dots to navigate the package hierarchy. Absolute imports are generally preferred as they're more explicit and easier to understand. Relative imports are useful within a package for referring to sibling modules. The number of dots indicates how many levels up to go. Different initialization patterns serve different purposes. Exposing specific items creates a clean public API. Importing submodules provides access to everything. Lazy loading improves startup time by delaying imports until needed. Choose the pattern that best fits your package's needs. Python comes with a rich set of built-in modules. These modules provide essential functionality for common programming tasks. Familiarize yourself with the standard library to avoid reinventing the wheel. Each module is documented in Python's official documentation. Adding a _main__.py file makes a package directly executable. The M flag tells Python to run the package as a script. This is useful for creating command line tools or standalone applications. The if __name == _main__= idiom ensures code only runs when the package is executed directly. Setup.py is used to create distributable packages. Find _packages automatically discovers all packages in your project. Install _requires specifies dependencies. This structure allows you to distribute your package via PyPI. Always include documentation and requirements. Follow a clear organizational structure. Use explicit imports to prevent namespace pollution. Use explicit imports to prevent namespace pollution. Document your package and modules thoroughly. Keep related functionality together. Use version numbers and author information. Consider backwards compatibility when making changes. We've covered the core concepts of Python modules and packages. These tools are essential for organizing and distributing Python code. Remember to focus on creating clear, maintainable package structures. Good organization makes code easier to understand, maintain, and reuse. Practice these concepts by breaking your own projects into well-organized packages.